download the fractions1.xls file from the link below from our website. What you'll notice is it has been updated. If you go to File, Properties, select the file in its Properties, in Details section, you've got revision number 2, version number 1.1. If this revision number doesn't exist or the version number doesn't exist, then it's an old version of the file. I've currently updated it, and there's new worksheets added to this file which you can use and download and use with your child. So let's just, once you've downloaded the worksheet, let's just run the worksheet. I'm going to explain what changes I've made to the existing worksheets and how I've added new worksheets. As you can see, currently I've added 2 more worksheets to this. The fractions worksheet still has the original fractions worksheet, shape fractions worksheet and right fractions worksheet. But I've made changes to these. Just to explain, the first one, shape fractions worksheet, remains still the same. Shape the fractional part shown below. Again, it's auto-generated by pressing F9. The second worksheet, right fractions worksheet, is slightly different from the original one. Write down the fractional form for the following is what I've added, and now you can see 2 sections that exist for each question: a shaded fractional form and a non-shaded fractional form. Once you download the worksheet and you print it off using File, Print, what you'll see is this printout, and what you do is basically shade this worksheet in and then get the child to write the shaded fractional form and the non-shaded fractional form for this particular shape and all the other shapes in effect. So once you've done that, that is straightforward. You can also teach them how to cancel down the fractions based on the original shapes, but again, it's up to you how you make use of the worksheets. The other 2 worksheets I've added currently are addition worksheet for the fractions addition part and the subtraction worksheet. Again, it's more visual and more interactive in the sense that you would add fractions using the diagrams here on the side. What you've got is basically half plus a half. Again, what you do, even though this first shape is a rectangle and there's another rectangle next to it, it's divided into 8 sections, but you need to color half of that, which means you would color 4 sections in for the first half representation, and the second half representation you would color another half of it in, but not on the second rectangle, but starting with the remaining part of the first rectangle. When you color that half in, the amount that you've colored in altogether would be 1 whole 1. You've colored 1 whole shape in, and half plus a half would mean 1 whole 1. Similarly, you've got a quarter plus 3/4 or 6/10 plus 3/10. Let's take a look at the 6/10 plus 3/10. This pentagon is divided into 10 equal parts. The 6/10 would be, if we color 6 of these parts in, you would get 1, 2, 3, 4, 5, 6 colored in, and the 3/10 we would continue to color those 3/10 in as well. 1, 2, 3. Now when we colored all those in, is what we get is 9/10, which is colored in, and that is how we add fractions. Because there is a common denominator, it's straightforward there, but further down, as there is no common denominator, it gets slightly more involved and more difficult. But it's again how you make use of this visual drawing and how you use the shapes. So I'm going to explain a bit on that as well. 5/6 plus 1/3. 5/6 would mean you would divide this. Let's take a slightly easier example. If we go for a half plus 2/4, or half plus a third, I think is better. If we go for a half plus a third, what we would have is we need to divide the first square and the second square into 2 equal parts first, So let's divide the first square into two equal parts through the middle, and we've got one part on the left, one part on the right. Now we divide the same first square into three equal parts. That's going vertically once, now horizontally twice. So if we take it horizontally once, then horizontally again twice, we would have 6 parts in all in the first grid. Similarly, we do the same section, so we would have 6 parts in the second square object. Now that we've got 6 parts in each of these squares based on 2 equal parts and 3 equal parts, the first part says we need to color in half of it. Now based on our half horizontal, we color the top half of the square in. Then for the third, we look at the second grid and we need to color a third of it in. Now to do that, we have divided into basically 2 equal parts and 3 vertical sections. Now to color a third of it in, we would color one of those vertical sections on the second bit, but without coloring it in, we just visualize it. We don't color the second one in. Once we visualize it, what we see is we've actually colored in 1 and 2 sections out of 6 sections in the grid. Now when we colored the top half of the section in on the first square, we've colored in 1, 2, 3 sections in. We need to color in 2 more sections for 1/3. 3, 4, 5 sections, in other words. That would give us 5/6 as our answer. So in effect, what we would have here is 5/6 as the bit that we've colored in, and that's how we add fractions visually. Similarly, question 6 is the same. 7 is slightly different, as we have a common denominator. We do not have to put the whole number part on the top as a fractional form. We can just add the whole number parts in and then add the fractional parts in by coloring in the grid, and we can do that separately. So it's up to you how you want to handle that. With number 8, is slightly more involved. It's similar to 5 and 6. You may find that you may need to add more of these rectangle shapes in order to divide it into what you need, in effect 5 equal parts and 2 equal parts. But what you need to do here is make sure you put the whole number as a form of a 3/5 fractional form. So make sure you put 3 whole ones in the form with a denominator of 5, and add it to the 3/5 you've all currently got. Similarly, with the 4.5, you need to put 4 over 4 whole ones, which would over a denominator of 2. But to do that, it'd be 8/2, and similarly the 3 whole ones would be 15/5. Then you add the 15/5 to 3/5, because you've got common denominators. 15, 16, 17, 18/5 is what you would get. Still a common denominator of 5. Similarly here, this part would be 8/2 plus that 1/2, which is 9/2. And then you divide this grid as you would normally for the way I've explained that number 5 above, and then you start coloring them in and see how many sections you need to color in accordingly. That's basically it for that one as well. Again, this entire sheet is randomly generated. If you press F9, you would get new sums generated for you, and I've left enough space for you to write the fractional form as well as the whole number part if necessary. So just press F9 to regenerate the addition worksheet. Let's go on to the subtraction worksheet. It's very similar in that this is again auto-generated by pressing F9, and what we have here First 1 to 4 questions are straightforward as they have common denominators. What you do, 4/8, you color the first part in, 1, 2, 3, 4, 5, just shade it in lightly so you can rub it out for the when you're trying to subtract it. So rub the top 4 sections, shade the top 4 sections in roughly, so you've colored half of that in. Then remove 3 sections of those, so just rub the 3 sections out, shade 4 sections in, rub 3 sections out, and you've got 1/8 shaded in left, so that would basically become 1/8. That's how you would use that. Similarly, number 2, half, you color half of that shape in, shade it in, then you remove the same half that you've shaded in, and what you get is 0. So half minus a half would be 0 in effect. 4/5 minus 1/5, again you need to, because it's a pentagon and you've got 2 triangles representing one side of the pentagon, to shade 4/5 in, you'd say 1, 2, 3, 4, 5, 6, 7, 8 triangles in. Yeah, so 1, 2, 3, 1, 2, 3, 4, yeah, 8 triangles in, 8 small triangles. And once we've done that, you can remove 1/5 of it, so you just rub one of those triangles out, and you've got 1, 2, 3 fifths basically still shaded in as a fractional form, and that's basically what it is. Similarly here with the more involved questions, it's number 5, 6 and 8 are slightly different. Number 7 has a common denominator which you can use to subtract the fractional form and add the take away the whole numbers as is if you need to. Let's go through number 5. Basically 2/3 minus 1/5. So again, what we would do is divide, using the common denominators, we would divide the square into 3 vertical sections, 1 and 2 lines vertically would give us 3 vertical sections, and a fifth. So that would mean horizontally we would get 1, 2, 3 and 4 lines, which would mean we've got 5 vertical sections, horizontal sections going across. Now each one of these would mean there's a total of 15 equal parts in this first square. We would have a similar 15 equal parts redrawn on the second square to easily subtract this. Now 2/3 would mean, because we've got 3 vertical sections, we would color the first vertical section in and the second vertical section in. Now 1/5, as we know, we've divided it into 5 horizontal sections, and the first horizontal section, if we look at the second grid, we would have approximately 1, 2, 3 of those first sections colored, 5 horizontal ones, and take those 3 in your head. Don't color it in on the second grid, but remove that amount from the 2/3 that we've colored in. That includes basically 5 and 10. We've colored in 10, so we need to remove 3 of those, and we would have 7 colored in over 15 altogether. So it would be 7/15 in effect. It's quite difficult. I believe I've got it right, but I haven't exactly. I'm just doing this on the fly. I believe it's 7/15 as what we've got based on how the divisions work. So you can cancel them down if you do come across cancellations, but similarly you do the same thing. Make sure you put the 5 whole ones over a reasonable denominator and the 1 whole one over a reasonable denominator, then make the divisions of the shape before subtracting, and it would work really well for you. Try it yourself with your child, or even in a classroom if you're a teacher. I believe it does work, and auto-generate F9 to auto-generate the worksheet as many times as you like, and you'll get more different and wonderful fractional sums, addition and subtraction. Keep a lookout on my website for an updated version of this worksheet, because I may be working on towards producing multiplication and division sections as well. More visual form of creating multiplications in fractions and division in fractions. So keep a lookout. An updated version. Again, this is version 1.1 of the worksheet, and I've added 2 extra worksheets to it, and I've made modifications to the right fractions worksheet as well. So have a look at it. +1, Google +1 it on my website if you like it, or Facebook like it, please. Cheers, bye.